Hi, and welcome to today's lesson on trigonometry. We're going to be extending our knowledge of trigonometry and moving on to exact values and graphs. This is lesson 10 in my GCSE preparation course series, aimed at helping those in year 10 prepare for their GCSE next year. So it covers all the main topics that people often struggle with and just gives you a quick recap and a chance to practice questions. You can download all of these slides in advance from my website, so you should download them before the lessons if possible, and then you can have a go at the starter questions, because I try to design these as topics that you need to be aware of before the lesson. So for example here, it's just a lot of surds work, because that's what our exact values involve. Okay, if you haven't had a chance to have a go at them yet, then you've got about a minute or so now to choose a few that you might need to recap while we wait for a few more people to log on. Alright, so just try some of these starter questions. Remember, if at any point you get stuck or you have a question for me, just type it into the chat box and I'll answer you as soon as possible. These lessons are recorded in advance, but I watch live along with you so that I can help anything that you're stuck with and answer any questions you've got. Right, welcome if you're just joining us. We're just trying some of these starter questions. Just a reminder, they're all downloadable from my website, mrsk'slightbulbmoments.wordpress.com. Okay, if you just want to finish the question you're on, I'm going to put some answers up in just a moment. Alright, let's have some answers. On the screen now then are the answers for all those questions. I'm not going to go through any of them in detail. If you get stuck on any of them, then it might be worth, if you're watching this in your own time, to pause here, go back and watch my surds lesson, which I think was lesson number 2 off the top of my head. Go and watch that and see if that helps fill the gaps. If you're still a bit stuck, then please do comment below the video and I'll help you where I can. So the first one was just our generic simplifying. We've got to make sure we can take out any large square numbers. 2, rationalising the denominator. You've got to get rid of that surd on the bottom sometimes. And question 3 was manipulating surds. So a bit of multiplication in there, a bit of your fractions work, some division in question D, and some brackets in E. As an extension there, we had draw all 3 trig graphs and write out the table of exact values. I'm not going to show you answers yet for that because we're going to come to that in the session. Hopefully we'll get a lot more familiar with using both of those things by the end of this session. Right, let's get started. So, today we are going to look at exact trig values and trig graphs. In the future, that means we still have to cover 3D Pythagoras, 3D trigonometry, and the sine and cosine rules. So just to kind of give you a bit more up to date on where we are within our trigonometry topic. Okay, so we're going to start off looking at the exact values. Now, you might have learned them from these triangles, which have the special sides 1 and 2, which means that we can work out the other side as root 3, and the isosceles right angle triangle, which is 1, 1, and gives us a side of root 2. They've got all the angles we need there, 30, 60, 45. That's sort of the understanding, the conceptual way of where it comes from. So that's the way a lot of teachers go into it. You might have just got the table of values and just memorised it. and that might be the way that works better for you. You don't need the conceptual understanding of where they've come from, but you just need to remember the values. Or you might have any other techniques. There's a way you can do it on your hand by counting your fingers. There's so many methods to choose from, and I think sometimes it's a bit daunting. I'm not going to go through all of these methods today because this is just sort of more of a recap session, but I'm going to focus on the table because this is the way I teach it. I obviously go through the conceptual bit first, but this is the way I really, really revise it and drum it into my year 11s. And I do a similar thing to this hand trick, but it's going through the table and writing out the table as it goes. So I'm going to show you how it works. If you've got a method, so for example, if you use one of those other methods and you're fine with it, then stick with it, brilliant. But use this time to practice it. Can you write that table down? Do you remember what angles are at the top of your table? Because you need to be able to create it on a table eventually. So I'm going to show you how I do this. You'll see on the left I've got a rough version and on the right I've got a neat version. Really important to have the two because it does get a bit scrappy. And I would suggest at the beginning of a non-calculator paper, so as soon as you've got into that non-calculator paper, write this down. Okay, anywhere in your paper you can find, write this down, because then it's there, you've got it while it's fresh in your mind, you don't have to panic about it later on when your mind's gone blank, and then if an exact value question comes up, you can just flick back to it. So it's a really good one just to have in the front of your mind to write down as soon as you get in. So I'm going to show you how we work this one out, and it is just following a bit of a pattern. You do have to know it goes sine, cos, then tan. Sine, cos, tan. You should be familiar with that method because that's what you've got on your calculator as well. It's sine, cos, tan. Obviously you wouldn't have your calculator with you in a non-calculator paper, but I think you're so used to seeing them in that order. Sine, cos, tan. Along the top, these are the angles we're interested in. 0, 30, 45, 60 and 90. It's just practice with remembering those special angles, I'm afraid. Right, once you've got your table written like that, now you can start to fill it in. The first bit we do is we start at 0. We just go 0, 1, 2, 3, 4. Nice and simple. Then on the row below for cos, we do it backwards. 0, 1, 2, 3, 4. Okay. Now we're going to square root everything and put it over 2. Square root over 2. Square root over 2. Square root over 2, square root over 2, and so on. Okay, and then we're just going to need to simplify it. But that is it for the trickiness of writing it down. It's just the numbers 0 to 4, one way, then the other way, and then square root and divide by 2. So if we go back to our full screen, we'll see I've got that neat version here because we are going to need to simplify these a little bit. Now look at that first one, the square root of 0 divided by 2. Square root of 0 is just 0, divided by 2, still 0. Square root of 1 is 1, 1 divided by 2 is a half, so that one just simplifies to a half. Root 2 over 2 we can't simplify, that stays as it is, same as root 3 over 2. Root 4 is just 2, the square root of 4 is 2, so 2 divided by 2 is 1. Okay, so that is our first row, exactly how you need to remember it. 0, half, root 2 over 2, root 3 over 2, 1. Then obviously our second row, our cos, is just the same backwards because we have those exact same terms, just backwards. So you could just write down 1 in your rough stage and then just copy it backwards on this stage. Okay, so sine 0 to 1, cos 1 to 0. Now we've got to work out tan. Now tan, we've actually got a formula. You don't need to know at GCSE, but just to show you where it comes from, that tan theta is the same as sine theta divided by cos theta. So all that means is you do your value for sine divided by your value for cos. So let's look at on our neat version here. To find tan of 0, we've got to do 0 divided by 1. 0 divided by 1 is still 0. Now on the next one, half divided by root 3 over 2. Now I'm just going to do this over here. I'm going to do it in blue so you can see where I'm working. A half divided by, so I'm going to change that to a multiplied by. Rather than root 3 over 2, we're going to flip it 2 over root 3. Okay, so I've done half divided by root 3 over 2 and flipped it. So therefore we get 1 times 2 is 2 over 2 root 3. Now can you see what we can do there? Cancel those 2's. So we actually just end up with 1 over root 3. So in my neat version there, I've got 1 over root 3. Now I don't do this every time I do the table now. I don't want to do that division and that multiplication, the fraction, the cancelling. I just learn the tan row off by heart. I'm just showing you how you can get it if you get stuck. Okay, let's look at the other one. I'm just going to rub out those blue workings there. So we have got root 2 over 2 divided by root 2 over 2. Now anything divided by itself will always give you an answer of 1. Next one, root 3 over 2 divided by a half. Now if you divide by a half, that's the same as multiplying by 2 because you flip that fraction. So root 3 over 2 times by 2 is just root 3. You could do that the long way and cancel it all out, but that's what you get. Root 3 divided by 2 times by 2 gives you root 3. Now the final bit, 1 divided by 0, you cannot divide by 0. It doesn't mean it just stays as 1, it means you cannot do it. So we can't get an answer. So we either write non-applicable or undefined. But it basically means there is no way that tan could be 90 degrees. Okay, and that's your neat version. So you see how I got the first ones? That was quite quick. 0, 1, 2, 3, 4, square root it and over 2, and then do the opposite for cos, do it in reverse. And then for tan, I just learned this bottom line, because it's quite a nice pattern itself. 0, 1 over root 3, 1, root 3. And if you notice, it's actually in ascending order. Those numbers are getting bigger. 1 over root 3 is quite a small number. It's less than 1. Then we get 1. Then we get the square root of 3, which is obviously between 1 and 2. All right? Now I'd like you to have a go. So I'm just going to give you 10 seconds. Look at my method. Look at that tan line. And then I'm going to change the screen and you're going to try and copy it down. So I hope you've got pen and paper ready. 10 seconds. Right. Your go. Okay, finish it up. And let's check your answers. Okay, check with my table there. Did you get it right? Just a little aside, you might have on this bottom one, for tan of 30 degrees, we've got 1 over root 3. Just a little recap of rationalising the denominator. You see we've got a surd underneath there. Sometimes you'll have learned it with the surd not there, so you'd have learnt it as root 3 over 3, because if we rationalise it, we end up with root 3 over 3. Okay, so these two are equivalent. You could have either one of those in that cell. 1 over root 3 or root 3 over 3. They mean the same thing. Okay, fab. It's just about practice for these ones, so get it really familiar. Keep testing yourself on it. It's something you can do really, really quickly if you've got a spare moment at any point. Get a family member to shout it at you randomly over dinner or breakfast, and you have to try and repeat it. If you've got your own little mini whiteboard at home, it's great to be able to do it and rub it off. Okay, we're going to use this throughout today, but I will have a version on the screen if you need to look at it at all. Okay, so we are going to look at how we actually use those values, because we've learned what they are, but a question, you basically use them in the same way as you would trigonometry, but without a calculator. So let's look at this first example together. I'm going to zoom in and do this one with you. So we have got a triangle here. Now with our exact values, we can still only use them on right angled triangles. So you'll see with this one, we actually need to cut it in half like this to create 2 right angled triangles. All right. So now let's just look at that left hand triangle. We need to find angle A. So we need to work out all the way over that side. So I'm going to start off by trying to find this side that I've just drawn in. So that's the opposite that I'm interested in finding, if this is my angle. Then that would be the hypotenuse. Okay, so I know I've got O and H, which tells me I'm looking at SO of SOHCAHTOA. I'm trying to find the opposite, so cover that up, and that tells me to do sine times hypotenuse. So sine 45 times my hypotenuse, which is 6 root 2. Now this is where normally you just type it straight into your calculator, but here we're going to use our table of values. So I've zoomed off it on the screen here, but got it written down, and you can use yours if you've got it. Sine 45 is root 2 over 2. And we've got to multiply that by 6 root 2. That gives us, on the top, we'd have 6 root 2 times root 2. Your root 2 times root 2 is just 2. So we'd have 6 times 2, which is 12, over 2, which is just 6. So that actually gives us a value here of 6 as my height. Okay, so just a little recap there. The 6 root 2 goes onto top of your fraction. 6 root 2 times root 2. Root 2 times root 2 is 2. So we've got 6 lots of 2, 12 on top of our fraction. Okay, now we can move on to the other side of our triangle. And we're interested in this angle here. So if I now label up this triangle, I've got my opposite, I've got my hypotenuse. So I'm still interested in SO, and I'm trying to find the angle this time. So you cover up sine, because remember sine theta, that's where the angle hides. Because we're trying to find an angle, we have to do inverse sine, so we're kind of undoing that, of my opposite divided by my hypotenuse. 6 divided by 12. Now simplify that first, because 6 divided by 12 is just a half. Now to do the inverse sine, it's basically working backwards. Which angle gives you a sine theta value of a half? Look at your table, the angle is 30. Okay, because under sine 30 you have the answer of a half. So we found that angle A is 30. You okay on that one? So it's a little bit of a tricky question. I put in a multi-step one there, but I wanted to show you both how you find a length and how you find an angle. I'd like you to have a go at this one now. Okay, 1 minute. Clue, you're going to split it down the middle just like I did. Right, draw a little sketch of it if you've got paper, or if you've printed out the handouts, draw it straight on there. Okay, off you go. I'm going to start writing in the answer. If you're still working yours out, that's absolutely fine. Carry on working it out. I'm just going to start writing in my workings. Okay, if you're done, do look up and see if you can work out what I'm doing and where I'm up to, see how it matches yours. But I'm not going to say it out loud yet in case you're still working through it. Okay, can you see the answer there now? Hopefully you finished yours in that time and looked up. So just the same skill, it's just working the other way around. I started with a right-hand triangle. We did sine 60, which was root 3 over 2, times by 2 root 6. So this was slightly more tricky there because I had to combine my surds to get 2 root 18 over 2. When you simplify root 18, you get 3 root 2. So we had 2 lots of 3 root 2, which is why that became 6 root 2 on the top. Simplify even further, you get 3 root 2 for that height. Then you can move on to the other triangle that you're interested in, plug in the 3 root 2. You get 3 root 2 over 6. When you simplify that, that's just root 2 over 2, which you've got in your table. And 45 degrees would have given you that answer. Are we happy with that? I know it's a little bit tricky, those ones. I am pulling a lot of things together, but this is an advanced topic. Okay, well done. Let's move on to some different, excuse me, some different type of questions. Now, that was a shape style question using exact values. This is slightly different. So it's more of a kind of numeracy question, but using these exact values. So we'll do the first one together and then I'll leave you to it. So we have got 5 sine 30 minus 11 cos 60 plus 4 tan 45. Now 5 sine 30 means 5 lots of, and then sine 30 is a half. Okay, just look at your tables. Minus 11 lots of cos 60. Now cos 60 is also a half if you look at your table. Plus 4 lots of tan 45. Now tan 45 is 1. Okay, if you're writing it out like I am, that really helps you see what you're doing, keeps it nice and neat and shows your substitution. When you simplify that, we've got 5 lots of a half, so 2.5 minus, got that one right there. Yeah, 2.5 minus 5.5 with the 11, and then plus 4, and that gets you back up to 1. Okay, 2.5 minus 5.5, add 4, and we end up at 1. Okay, a few things to point out in these questions. Can you see we've got sine 45 dot cos 45? That means multiply. Dot is just another way in mathematics of saying multiply. And here at the bottom, can you see we've got cos squared 45? That means cos 45, and then you square whatever that is. So rather than writing the squared at the end, which would look like just the 45 is being squared, we put the squared in the middle. So it means look at your table, find out what cos 45 is, then square it. Okay, now you're not going to have time to do all of these right now. I'm going to give you a few minutes, but if you are trying these in your own time, pause it, take as long as you need, and I'd like you to work out which is the odd one out and why. All right, off you go. Just a minute to try some of these now. Okay, try one more question. Okay, and answers are going to pop up. Remember to go back to this one because I think it tests some really good skills here, especially with surds as well. So go back to it in your own time and try for a bit longer. But answers are coming up. We should have got 1 for all of them, except number 10, which gives you 1 1/3. I did the answer to that one about 10 times just to check I hadn't made a mistake, but it is definitely 1 1/3. It's there to make you question yourself, make you think, is it really 1 1/3? Okay, super duper. Hope you're happy with those. Any questions or any problems, just put a note in the comments and I'll try and go through the question with you. Okay, These we're not going to do now, but I wanted to leave them up for you to try because they're some brilliant questions. And this is especially if you're thinking of aiming for the grade 8, grade 9, so really pushing that top. These are like the original shape ones we did with surds. We have to break them into different triangles, but they just get quite tricky, quite nasty, especially question 8. Okay, so pause it if you're watching in your own time. Have a go at these. Don't skip ahead and look at the answers. Really try and push yourselves and get these right because they're good questions. I really enjoyed these ones. These are all taken from Don Stewart, by the way. I just wanted to point that out. These two that I've just done, Don Stewart. Okay, answers coming up for these ones. Pause there if you want to mark. I've tried to give you some detail here of how I've done them. But if you've got any questions, just leave me a comment. Okay, moving on now. Right, well done on that. So that's our kind of exact values bit. We're going to come back to that in a minute, but we're going to combine it with trigonometry graphs. So these are the 3 graphs we really need to know off by heart at GCSE, and that's the graph of sine, cos and tan. Key points to note: with sine it starts at 0 and starts that nice lovely curve that repeats every 360. Cos is exactly the same but starts at 1, so it starts at the highest point. Lovely curve, repeats every 360. Tan starts at 0 and goes up exponentially, so it gets really, really steep by 90. And at 90, we've got those dotted lines. Can you remember what they're called? It's an asymptote. Okay, and that's a place where it can never be. Do you remember in our exact values graph for tan 90, what did we have written? Yeah, non-applicable or undefined. And that's because it just cannot be, it's impossible because we can't divide by 0. And you can see that on the graph as well. That's why we have those asymptotes, because the curve can never go on that line. So it goes up that asymptote and then it starts again from negative infinity right down the bottom, curves up towards 180, crosses and curves up again. Key things to remember when you're doing it is that something happens every 90. I get my students chanting this at me because they just forget where the values go on the x-axis. So if you remember either a turning point or an intercept, or in Tan's case we have an asymptote as well, happens every 90. So something. It's not that there's a turning point every 90 or an asymptote every 90. You just know something happens. So in y equals sine x, you'll see we have a turning point at the first 90. Then after another 90 we have an intercept at 180. After another 90 we have a turning point. After another 90 we have an intercept at 360. Okay, so it helps you get your labels. Include 1 and -1 on your y-axis for sine and cos. You will not get the mark if you don't put that on. Okay, it's quite strict on the mark scheme there. You have to have labels on your y and your x-axes. So include 1 and -1. Don't forget your asymptotes on the tan graph, on the curve there. So 1 at 90, 1 at 270, if you're just doing that pattern. And again, it repeats. And on tan, it's got 10 and -10 here, but you could use the infinity symbol. So you could have infinity as your top value and minus infinity as your bottom value, just to show it continues and continues to go up and up and up. Okay, these is just practice. It's the same. Pause the video, try them on a little bit of paper, check again, try it to keep testing yourself and you'll get them really familiar. Okay, we're going to now look at using these graphs. So this is one of those topics that a lot of people really hate. And I must admit, when I first did this at school, I didn't get it. I didn't get it at all. It was one of those, I call it like a PTSD topic for me. Looking back on it when I started teaching, I was petrified of this topic, hated it. But the more years and years that I've been teaching, I've grown to actually quite like it. I've had to obviously understand how it works. And I think once you can spot the symmetry in it, it's actually nice and simple. It's just like doing a reflection when you're in year 7 or something. But it's just, I think people struggle to spot it at first. So I'm going to try my best to explain it to you. This is one of those, that top grade topic. So if you can't get it, don't worry. Okay, it's one of those top grade ones. So here, we're just going to be looking at the symmetry of the sine curve. Can you see towards the top right, we've got a coordinate a, 0.5. Can you work out what should replace the a? Look at some of the symmetry. Can you work out what goes in front, what goes instead of the a? So I'll tell you the answer and then we'll see if we can work out why. Oops, I'll just turn my pen off. So it should be 150, 0.5. Can we spot why that is? So I'm just going to draw the diagram here. If you can see this 30, 0.5, that comes down at 30. This one comes down here. Now the curve is symmetrical. That means that's 30 out from the intercept. So this one must be 30 out from the intercept, which in this case is 180. So take off 30 from 180 and you get 150. So it's all about being symmetrical. They're all on this same line here in the middle. Okay, that goes through 0.5. And we know that because we know sine 30 is half 0.5. But it's just showing that symmetry there. Now, I'm going to zoom back out and see if we can try some of the others. I am just going to get rid of that mark that goes across that bit. Oh, it'd help if I'd zoomed out all the way. Okay, see if you can spot B and work out what the answer is going to be. So that's down middle at the bottom. What coordinate is missing from B? To reveal it, it's minus 30 minus 0.5, because with this one, it goes up to the graph there, and again, because it's cutting across at 0.5 or minus 0.5, then you know it must have gone the same distance in. There's all that balance of symmetry. So it must be 30 degrees out from 0, but it's just on the negative side rather than the positive side. Okay, try the next one. Can you see C? That's the top left. What coordinate should be there? Super, minus 330. That's just because it's 30 degrees out again from the end, which was 360. So it's 30 degrees out. D is the next one. Yeah, it's just 0.5 is missing. It's just showing you they're all on that same height. And we knew that because 210 is 30 degrees out from 180. E is down the middle at the bottom. What value are you missing there? That is minus 0.5. And now look at F and G together for me. See if you can work out what they are. So F is 330, because again we've come in 30 from the end. And G is minus 150. We've come in 30 from minus 180. The main tripping points here are getting your negatives all confused. So adding 30 to 180 and getting minus 210 instead of minus 150. So just be careful with negatives there. If it's still not clear, don't worry, we're going to do quite a bit more in the symmetry. So let's move it on and have a look at this. This is basically what we've just done on the previous slide, but I wanted to show you. Look at the bottom where I've written sine 30 is equal to sine 150, which is equal to sine of minus 210, which is equal to sine of minus 330. So those are all the blue crosses at the top of my screen. And it's just saying if you plug in any of those to your calculator, you will get the same answer, which is a half. Okay, they're all on that line. They're also equal to minus sine of minus 150. So all of these ones in pink are these ones that are underneath my x-axis, and they're equal to the above ones, but they're the negative version, aren't they? These ones would give you minus 0.5. So to make them exactly equal, we just put a minus in front of them. So minus sine of minus 150 is the same as sine 30. It would give you half. Okay? Let's have a little look at these statements then. So this time we're looking at the cos graph. Exactly the same, we're just going to use the symmetry still. I want you to see which of these statements are true. First one, does cos 30 equal cos minus 30? See if you can spot where that would be on the graph. Yes, it does, it's true. Those ones there are these two at the top here. I've just put in the crosses. They're equal. We don't know what they are, okay, because it's not an exact value. It's not going through an exact one on there. If you look at your table, you can work out the answer is actually root 3 over 2, but we don't need to know what it is. We just need to know they are equal. They're on that same plane. Okay, next one. Is sine 30 equal to sine 330? Now, I've just put this one in there to make sure you're concentrating. We can't answer that one because this is the cos graph. Okay, so just be really careful. You can only answer cos ones on this graph. That's why I put that one in there. Can't answer the sine one. So next one, is cos 30 the same as cos of minus 330? So have a little look for them. Cos 30 is here. I'm crossing it now. And cos of minus 330 is here. Yes, they're the same. Perfect. Next one. Is cos 210 the same as cos 150? Yeah, can you see them? They're both down the bottom. These two down here, and they are the same. They're actually minus root 3 over 2. But again, we don't need to know what they are, just that they're the same. Can you try this one? Is cos 150 the same as cos 30? So cos 150 is down here, cos 30 is up here. They're not the same. Cos 30 is root 3 over 2, cos 150 is minus root 3 over 2. So just be careful there, even though there's that symmetry to it, they are not the same. They're the negatives of each other. So what we need to do is, can you see what I've changed there? Is cos 150, so that's again this one down here, equal to minus cos 30? Yes, because minus cos 30 just means it will give us its negative version, which will actually be the same. Okay, so if you need to make two of them the same, just put one of them as a negative and it will change its sign. Okay. A few more of these then. Cos 150, is it equal to cos minus 30? No, it's not. Well done. I'm not going to go through any more drawing the crosses on, but I'm just going to check with you. Is cos of minus 210 the same as minus cos of 330? Okay, we'll go through this one just because we've got a few negatives. Cos of minus 210 is down here. You go to minus 210 and work out where it is on the curve. Minus cos of 330. So do cos of 330 first, which is up there. And then it wants the minus equivalent, so we switch it down to the negative. Yes, they're now the same. Okay, see how we did that one? Okay. That's all for kind of those ones, just spotting from the graph. We're going to look at how we can now use that to answer some questions using that symmetry. So look at this first one I've got for you. The question says, express in terms of the trigonometric ratios of acute angles. Sounds a complete mouthful. Trigonometric ratios just means sine, cos or tan. That's what they're called because they're ratios of different sides of the triangles. And of acute angles. So that's the key word here. All of these, you'll see, we've got either obtuse angles, reflex angles, we've got larger than acute angles, or we've got negative versions, which we don't want. So we want to try and make these positive acute angles, because they're easier then to work with. So you'll see with the first one, sine 170. If we look over at our graph, let's just do it here, I'll just write down the one we're trying to do, so you don't forget, sine 170. So can you look at where 170 would be? So on our sine graph, roughly here somewhere. Yeah? Now that is how far in from the intercept? It's 10 degrees in, isn't it? Using our symmetry, that means we've got to go 10 degrees in out here, and we've got to work out where that point is. Now obviously 10 degrees in from 0 is just 10 degrees. So that means sine 170 is identical to sine 10. Okay, do you see how we're using that? So we're just working out from the intercept. So you either count like we've done here, we've counted from the 180, gone in, or you can count from a turning point. So that would have been how to get to 170 from 90. We've added 80 in that direction. So we'd have to take away 80 in that direction. And you still see we still get to 10. 90 take away 80 is 10. Just about using that symmetry to find a positive acute angle. Okay, have a go at some of these. I'm not expecting you to do all of them, but again, they're there in case you want to practice this, because I know it's one of those tricky topics. So choose a few, some sines, some cos, some tans, some negatives as well. Have a go. Okay, just try one or two more. And let's have some answers. So looking at the screens, answers are now up. Check for any you've done. Any you're not sure about, just leave me a comment and I'll try and explain it. And it's just practice. You've got to draw it out. I really struggled for ages trying to do it in my head. And the best way, even now, I draw them out. I draw a quick sketch and I draw my lines and I work out where they are because it's so much easier to understand that symmetry and especially get the negatives the right way around. So draw yourself little versions of sine, cos and tan and draw them going negative as well, in the negative direction, rather than here just going positive. Just draw them both ways. Okay, we'll move on from that then. I've got one more little bit for you. So we've worked out how to put them into acute angles. So you'll see all of our answers here are acute. Brilliant. But now we're going to bring it all together. So this says, using the trig graphs, find the exact value of cos 135. So that would mean without a calculator, you've got to work out the answer to cos 135. Now that's not on our table. Okay, we don't learn the exact value of 135, but we can use the symmetry of the curve to convert it to an angle that is on our table. So here, cos 135 is the same as minus cos 45. Okay, I'll show you why that is if we just zoom into this one. So cos 135 was, let's say, about here. Okay, 135. Now that's gone in how much to get from 90 to 135? That's gone in 45 degrees. So let's use our symmetry to go back 45 degrees from 90. And what do we get to? We actually get 45 because it's half, isn't it? So this value here was what we wanted. We've now worked out that is cos 45. Can you see they're the negative equivalents of each other? Which is why our answer was minus cos 45, because we want the negative version of it. Now that we've got an angle that's on our table, look in your table box. Cos 45 is root 2 over 2. We wanted minus cos 45, so we want minus root 2 over 2. Okay, quite a few steps here, but it's pulling it all together. Have a go and see if you can do a few of those. So remember, use the graphs first to convert it to an angle that's in your table, and then use your table to write your final answer. Off you go. Just 1 minute. Again, choose maybe 2 or 3 to practice. Okay, just do one more. and your answers are coming up. Okay, so I tried to give you the acute equivalents and then from the table what you would get. Hope that makes sense there. Now, just some things to remember about the graphs. When you're doing this, you might have spotted a few patterns. If you're using the sine or cos graph, you can just add or subtract 360, and sometimes that will get you back to the right one. It doesn't work for every question because sometimes you've got the different symmetry and then the negative changes, but you can always take 360 off and see where it gets you, and it might be to the right answer. That's because the curve just repeats every 360, so it's always going to get just somewhere earlier on in the curve. For the tan graph, that's the same. You could take 360 off, or you could just take 180 off, because the tan graph actually repeats every 180. It doesn't need the full 360. So for example, up here are 300, tan 300. We could have said that was the same as tan of 120. So just straight away take off 180 and then see where that gets us. And then tan 120, can you imagine taking 180 off of that again? We've got to tan of minus 60, which again would work and shows us with our symmetry that tan of 60 would give us the negative version. All right, bit of a mouthful there, but it's just some things to spot if you try to spot a pattern there. And with the cosine curve, because it's symmetrical about 0, so just draw it on our curve here. Remember, it would extend and go down and so on, symmetrical. That means a 90, if it's positive, will give you the same as 90 if it's negative, and that would go up to cos of 1,000 would be the same as cos of minus 1,000. So for cosine, it's quite handy to know that they'll just be the same. It doesn't matter on the sign. All right, really well done on those. They're really tricky questions. And I really hope that's helped a little bit with pulling together the exact values and graphs. It's a tricky topic to learn, and it's quite a tricky topic to teach, especially just over a PowerPoint. So maybe you need to watch it a few times and do a bit more of the practice, but I would recommend going back to finish some of the questions. Okay, the whole PowerPoint with all my annotations can be downloaded on my website, mrsk'slightbulbmoments.wordpress.com. If you want any more practice questions, Corbett Maths has some questions, 338 to 341, although they tend to be a bit basic. They're not as high end. They're probably the bare minimum of what you need to know rather than the top grade questions. My next lesson will be next Monday, and it's on YouTube and Facebook at 5 p.m. and we'll be looking at the sine and cosine rules, so moving on to non-right angled trigonometry. Alright, subscribe if you can and give my video a like, that would be fab. I'll see you next week. Bye!